Welcome back to Simplifying Radicals. We already talked about the conditions for simplifying a radical. We talked about the quotient rule and the product rule for radicals. So if you need a quick refresher, watch the video prior to this one. But we're going to go ahead and get it started with some of these examples. So there's essentially two different methods I like to use when simplifying radicals. And I have found that students like using a mixture of both. There's not one correct way to do it. Sometimes one is faster than the other. I think it's important to know both, but generally over time, I think students are split 50-50 over which method they like, okay? So try to at least identify with one of those methods that I present. So we have square root of 24 here. I'm going to show you how to simplify this using both methods. So the first method is to look for perfect squares or cubes. Okay, in this case, we're taking the square root as indicated by the radical and the index. Okay, there's no number there, so it's implied that it's a square root. And because we're looking for the square root, we're going to be looking for perfect squares. Okay, now, what do I mean by looking for perfect squares? I'm looking for factors of 24. So if we're looking at factors of 24, I have 8 and 3, 24 and 1, 12 and 2, I have 6 and 4, and I think that's it. So of those, which of these are perfect squares? Well, only the 4 is a perfect square. So what I'm going to do using this method is I'm going to rewrite square root of 24 as the square root of 4 times the square root of 6. Why do I do that? Well, because I know that I can simplify the square root of 4. This is 2. Square root of 6, the only factors square root of 6 has is 3 and 2. It cannot be simplified any further. So this is just going to stay how it is. And your answer is 2 times radical 6, 2 square root of 6. Okay, that's the first method. As you get better at recognizing factors and perfect squares, I think this method is the fastest. But when the numbers get bigger, you generally need to use the method 2. So let's take a look at method 2. Method 2 is about using the factor tree. Because this is a square root, we are going to be using something slightly different than if it were a cube root. So the factors of 24, I always look for prime factors first. So let me write my prime numbers. Actually, I'll go ahead and do that later. I'm going to try to divide by prime numbers. So as I make a factor tree, 2 times 12 gives me 24. That's why I write those. 2 times 6 gives me 12. And then 2 times 3 gives me 6. Okay, I'm going to highlight the prime factors. Okay, it's best to divide by prime numbers every time. That way you can easily identify your factors in your factor tree. Okay, now because we're looking for the square root, we are going to look for any time we see a prime factor twice. So there we have two twos, 2 prime factors, and so that's important. What's going to happen is, what we can do is we can write, I'm going to show you the long process, and then I'll show you the quick process in a second. We can rewrite this 2 times 2 like this. So we have the square root of 2 times 2 times the square root of 2 times 3. Essentially what I'm doing is I'm trying to pair up perfect squares, okay? Because 2 times 2 times 2 times 3 equals 24. So if I break it down to its factors, I'm going to look for perfect squares. And anytime I have a pair, that's going to make a perfect square. Okay, so this is essentially the problem. We just have a 4 square root of 4 times square root of 6. So we get 2 radical 6. And let me erase this right here, and I'm going to show you the quick way. So anytime you circle a pair, 1 comes out of the radical. Okay, notice how there's 2 2's here, only 1 comes out from the radical. What stays underneath the radical is the 2 and the 3, which you need to multiply together to give you 2 radical 6. The way I like to think of it is there's 2 2's inside the house. So if we were to rewrite this, we would write it as 2 times 2 times 2 times 3. These 2's have a date. Okay, they have a date. They're at home right now. The home is their little radical. They're at home, but since they have a date, they can leave the house. So they leave, and they become a 2 outside the house. The 2 and the 3, they don't have dates. Okay, they need another 2 or another 3 to leave the house, so they stay home and they get multiplied, and it becomes square root of 6. So that's the way I like to think of it. This is especially useful for longer problems. So I hope that is helpful for you, and you can choose whatever method is most valuable. Okay, I'm going to shrink that a little bit. Okay, now we have a bigger problem. So we have square root of 108. Okay, so I know because I've been doing this a while, I know that we have a big square factor, which is, let's see, 36. 36 goes into 108 3 times. So I could rewrite this as square root of 36 times the square root of 3. Okay, that would be the quick way, because then I get 6 radical 3. For those of you that aren't experienced with knowing that 36 is a factor of 108 and that's a perfect square, you're going to want to use the factor method, or the factor tree. So I know it's 2 and 54. I'm going to try to divide by prime numbers each time. So that's 27. That gives me, I'm going to divide by 3, and we get 9. Notice how I'm trying to keep the prime numbers all on the left side. Okay, that just keeps me a little bit organized, and I have 3 and then 3. Okay, now I'm going to circle anytime I have a pair. So I have a pair here, a pair of 2s, and I have a pair of 3s. The 2s can leave the house. There's 1 2 that's going to leave. There's 1 3 that's going to leave. This guy, and I like to box him, he's going to stay home. So 1 2 comes out. He gets multiplied by the 3 comes out. And then we have the radical, and the 3 is home alone. So it becomes 3 radical 6. And that's our answer. Okay? That, to me, is the easiest way to understand factoring and simplifying radicals. Here we go, square root of 10. Are there any perfect squares in square root of 10? No. If we use a factor tree, we have 2 and 5. There's no pairs, so square root of 10 is as simple as it gets. Okay, so there's our answer. Okay, maybe take a stretch break, pause this video, big stretch, get some water. Okay, pause. All right, unpause. Here we go. We're going on to letter D. Now, this is different. Now we don't have a square root, we have a cube root. What does that mean? Well, now we're going to be, if we're using method 1, we're going to be looking for perfect cubes. So this one's a little bit tougher. Okay, what number times itself 3 times is a factor of 16? It turns out that the cube root of 8 is a factor of 16, and that's a perfect cube. And then we would need to multiply this by 2 still. 8 times 2 is 16. So now we know that the cube root of 8 is 2. We can't simplify cube root of 2, so then this becomes our answer. Okay? That's the way to do it using method 1. For those that need the factor tree, let me show you how it's done. Okay? So actually, let me shrink wrap this. Shrink wrap. Move it to the side. Okay, and I'm going to need to write this up here again. So cube root of 16. Again, we need to break it down into its prime factors just like we did before. Okay, so 2, 8, 2, 4, 2, 2. Okay, now they're all inside the house. So if we wanted to, we could rewrite this as cube root of 2 times 2 times 2 times 2. Okay, so they're all inside the house. They're all inside this cube root radical. Now, the 3 out in front means that's how many need to group together to leave the house. Okay, so before you just needed a date. Now you need 2 dates. So here we have 3 2s. So they're going to be able to leave, and 1 comes out. 3 2s, 1 comes out of the radical. Okay, so what does that look like? We have 1 2 come out of the radical. 1 2 stays home. I like to box the ones that stay home. And we get the same answer, okay? Get the same thing. Let's move on to a little bit more advanced problem. Now we have 4th root. I hope you guys realize now that we need to find something that is a perfect factor of the 4th degree. So what I'm going to do is, I don't know any perfect fourth roots. So what I'm going to do is I'm just going to go straight to factor tree on this one. So I'm going to say 2 and 81. Okay, I'm going to divide this by 3 and I get 27. I'm going to divide this by 3 and I get 9. I'm going to divide this by 3 and I get 3. And that's it. I have all my factors, okay? I'm going to highlight my prime factors. Okay, they should be all factored to its prime level. Now, because I could rewrite this problem as the fourth root, I need the negative sign up front, fourth root of 2 times 3 times 3 times 3 times 3. The 4 tells me how many can leave the house, okay? How many need to be grouped together to leave the house. So in this case, I have 4 3s. 1, 2, 3, 4. So 1 3 is going to leave the house for the 4 of them. So we're going to have a 3 out front. Don't forget the minus sign that's there. Okay, drop down the minus. Okay, that's the minus touch right there. Then I have the fourth degree there, the fourth root. Sorry, not degree, fourth root, and then this is 2. So there's my answer. The 2 stays home. I forgot to box him. He stays home by himself. So he stays in the radical, fourth root of 2, and then we have it times -3. Let's do the same thing. I hope you guys are catching on to the pattern. I don't know any perfect fifth roots there, so I'm going straight into factoring. I know this is 2, 32, 2, 16, 2, and what is that? 8, 2, 4, 2, 2, okay? Lots of 2s. 1, 2, 3, 4, 5, 6. This 5 tells me that I need 5 grouped together to leave the house. So 1, 2, 3, 4, 5. Okay, and then 1 is staying home. So I can rewrite this. This 1, 2 comes out. The 2 stays home. Fifth root of 2. Okay, so that is how you simplify the radical for any of these type of roots, no matter what the index is. We're going to do a few more examples because I'm sure you guys need the breather, as do I. I'm going to get some water, and I'll be right back after these messages.